Okay, let's look at the solution of this paper. So for example 1, in the figure, O is the center of the circle and BA equals to BC. You need to find the value of theta. First of all, we can find this one, that is 200 degree. Okay, no, 260 degree. Because there's a whole circle is 360 degree, so 360 degree minus 100 degrees, you get 260 degrees. So you can see there's an angle at center, so the angle at circumference will be 130 degree, because angle at center twice angle at circumference. So in this triangle ABC, you know that it's 130 degree now, and these two angles will be equal. So 2 theta plus 130 degree will be 180 degree, and you can find theta, that is 25 degree. So the answer is B. For second question, in the figure, O is the center of the circle ABCD. OD and AC intersect at E. Angle CAB is 27 degrees and angle ACD is 23 degrees. So find angle OEC. Now, some of you may make the mistake that they may think this is also equal to 27 degrees. It is not true, because these 3 points CDA are on the circumference, but O is on the center. So you can use angle at center twice angle at circumference. That is, angle DOA will be twice of angle DCA. So you can find this angle, that actually that is 23 degree times 2, that is 46 degree. When you find that is 46 degree, so you can find angles OEC, that is 27 degree plus 46 degree, that is 73 degree. So the answer is C. For question number 3, in the figure, chord AB, that is 6 cm and is 11 cm from the center O. And a chord CD is 9 cm from O. Find the length of CD. So we can do it this way. Try to think, okay, if AB is 6 cm, so the half of these two parts will be 6 over by 2, that is 3. And we can join this line, that is called as R. So you can find the radius of the circle, that is by using Pythagoras theorem, R, then you will get that is square root of 130. Also, that is 9 cm here, and you don't know the whole length of CD, it doesn't matter. We let this part be y, and the other part also be y, because it is the perpendicular line from center to the chord CD. Since you know that OD is a radius of the circle, is also square root 130, so you can apply the Pythagoras theorem again. Square root 130 square equals to 9 square plus y square. Then you get y squared, that is 49. So y is 7. But don't forget, you need to find CD. So CD is 2 times 7, that is 14. And therefore, the answer will be C. So let's go to question number 4. In the figure, O is the center of the circle. It is given that SOQ and PTR are straight lines. If angle PRQ is 42 degrees and angle STR is 95 degrees, find angle PRPQ, here, this one. And the problem is, you may not know how to find this. First of all, we try to do some question like this. First one, you know that is 42 degrees. Okay, and then you can consider this line. We call it as this one unknown x, and this is also x. Okay, and then we can try to find as many angles as you can. Then that's 42 degrees, and that is 180 degrees minus x minus 95 degrees. So you get that is 85 degrees minus x. And also, you can also find this angle, that is 180 degrees minus 42, that's 138, and then minus 85, so that is 53 degrees. So you can find RPQ that is 53 degrees plus an unknown number. And one of the very important character we need to use is SOQ is the diameter of the circle. So 53 degrees plus x equals to 90 degrees, and hence x is 37 degrees. So the answer is D. And for question number 5, arc length of AB, they occupy 2 parts. BC occupy 3 parts, CD arc 4 parts, and DA occupy 6 parts. Find angle BCD, and we can draw a line like this to cut this angle BCD into 2 parts. So the arc length ratio will same as the angle at circumference ratio, so that is 2K, 6K, and then here 4K, and finally 3K. So we can find K by adding these 4 angles up, because in this cyclic quadrilateral the sum of the opposite angles will be 180 degrees. So 7K plus 8K equals 180 degrees, and you can find K, that is 12 degrees. So angle BCD would be 8 times 12 degrees, that is 96 degrees. The answer is A. So, and go to the question number 6. In the figure, 2 circles intersect at point A and D. O is the center of the circle ACD, and BCD is a straight line. For this angle, ACD is 115 degrees. Find angle ABC, this one. Okay, let's see what we can do. Since this angle is 115 degrees, there's an angle at circumference. So if you multiply by 2, this is 230 degrees. Angle at center twice angle at circumference. And inside this one will be 130 degrees. Use 360 degrees minus 230 degrees. You get 130 degrees here. And now consider the big circle. ODBA is a cyclic quadrilateral. So the sum of the opposite angle would be 180 degrees. And hence this is 50 degree angle ABC, 50 degrees. So answer would be A. Again, this is 115 degrees. So angle at center twice the angle at circumference, that's 230 degrees. So we use angles as a point, find this angle DOA 130 degrees, and use the cyclic quadrilateral the sum of the opposite angles would be 180 degrees. So angle ABC would be 50 degrees. For question number 7, in the figure, AB is the tangent to the circle at P. SRQ will be 123 degrees, and angle QSP is 48 degrees. Find angle SPA. Okay, so you can know that we know this one is 48 degrees also because angle in alternate segment. And next, consider this opposite angle cyclic quadrilateral. This is 180 degree minus 123 degree. That is 57 degrees. And finally, you can get this answer by using adjacent angles on straight line. 180 degree minus 48 degrees minus 57 degrees. So final 75 degrees. And the answer is D for dog. So go to this one. Angle C is 90 degrees, and the semicircle DEGF touch the length AC and BC at F and G respectively. AC actually is 6, and BC actually is 8. Now you need to find the length of DE. So what can we do? And first of all, we can assume we can join the center, let it be O, and here actually is from the right angle here because tangent perpendicular to radius. And one more point is, since we know that these two lengths will equal to R, therefore actually these two also equal to R, and this form the square here. AC, that is 6, so AF, that is 6 minus R, and here that is 8 minus R, and you need to find the length of DE. That means you need to find the diameter of this semicircle. So what we can do is try to think in this way. Since we can observe that we assume this one is theta, so that is 90 degree minus theta, and that is theta, that is 90 degree minus theta. You can observe that AFO is similar to OGB. AFO is similar to OGB. So you can consider the length ratio 6 minus R over R, which equals to R over 8 minus R. That you can set up the equation to find R, and 6 minus R times 8 minus R equals R squared. 6 times 8, 48 minus 14R equal to 0. R, that is 48 divided by 14, that is 24 over 7. And you need to find the length of DE, that is 2 times R. So the answer will be 48 over 7. And that will be answer A. Okay, go to question number 9. Suppose fx is a polynomial, f 2 bracket 2 over 3 equal to 0. Which of the following is a factor of fx? And what we need to do is we just set x equals positive 2 over 3 here, and then we find it back the divisor, find it back the factor, that is 3x equals 2, and then 3x minus 2 equal to 0. So this is the factor of the fx, 3x minus 2. The answer is B, B for boy. And then go to question number 10. Let hx be x squared plus mx plus n. When hx is divided by x minus 1, the remainder is 1. And here, when you look at this one, when hx is divided by x minus 1, the remainder actually, that is h positive 1. Just substitute back here. And the remainder is 1, that means h1 equals 1. Second, hx is divisible by x minus 2. That means the remainder is equal to 0 when it is divided by x minus 2. That means h2 equal to 0. Also, h1 equals 1. You have these two equations here. How to solve this? You should know what is the meaning of h2. So that is 2 squared plus m times 2 plus n equals 0. Also, 1 squared plus m times 1 plus n equals 0. Sorry, equals to positive 1. So you get 4 plus 2m plus n equals 0. And then m plus n equal to 0. Just take the difference. Just take the difference here. So m plus 4 equals 0. M equals negative 4. So the answer is B. B for boy. And go to question number 11. You need to simplify the expression. First of all, when you find that there's more than one term inside the bracket, inside the denominator, add the bracket to it. And then find the LCM, that's n minus 4 times n minus 5. The first expression, that should be 4 times this one, n minus 5. And then minus 5 times this one, n minus 4. Denominator cannot change so far. So that is 4n minus 20. And here, pay attention, minus 5m plus 20. So these two cancel, you just left negative n minus 4, n minus 5 in the denominator. Go to check the option. A, not possible. B, not possible. C, n minus 4, n minus 5, but there's a positive n here, not possible. It just left D. So here you can see that the negative sign is actually moved to here. Negative bracket n minus 5 actually becomes bracket 5 minus n. So the answer is D, D for dot. So go to question number 12. Find the HCF and LCM of these two expressions. Now look at the coefficient force. HCF will be 2. LCM will be 12. So when you just look at the coefficient, A, B are not the answers. And check the HCF of x, that's x to the power 1. LCM of x, that is x squared. So nothing you can eliminate. No, you can see that D could be eliminated. Okay, because that's x cubed, it's not possible. So the answer is C. Also, you can check the y and z. HCF of y cubed and y, that's y cubed. And HCF of z to c squared, that's z squared. That's its final answer, C. So that's the end of this paper.